this power system is able to restart itself from nothing, using its own power and some pretty clever engineering. It's using multi-phase. What does that mean? And how is it useful? Let's take a look. Okay, so power in Satisfactory. Pretty simple really, we've all done it.
So it all begins with your bulk standard biomass burner, or Bunsen burner as I like to call it. You lay one down, you go and collect some leaves from the local area, you go back, you stuff it in its mouth, it burns it, generates power, you go out and find more leaves. You repeat until eventually the local area is completely depleted.
That is until, of course, we discover coal. Miner goes in, conveyor belt's getting dumped, this goes here, that goes there, power lines get connected, and check it out. Coal power. This kicks out 75 megawatts. And I've also hooked up the coal miner and the extractor to the power station, so that when the power station generates power, hang on a minute, this might be a problem. Gonna need to think about this. Coal power, coal generator, miner, water extractor, connect them up. Coal goes in, water goes in, power comes out, lovely. But to start this, we need power. Can't feed coal or water without electricity. It's like needing your glasses to find your glasses. So we kickstart it with a biomass burner. This starts the cogs turning and power flows to the factory. Job done. Right, here's where it gets interesting. So we have our eureka moment and connect it back. Self-sufficient, like a teenager who's finally learned to make toast. The system is self-sustaining, it's powering itself, we don't need a biomass burner, let's get rid of that. Now this works great until the factory grows, which it will. Something will give, the grid will trip, everything will stop, we've all been there. Restarting it as is, box of fuses in 3 hours of your life. So you need to disconnect the factory, drop the load, burn more dinosaurs, a couple more biomass burners, bit more oomph, and you're back online. Every time we expand and restart, more biomass burners. At this scale, it's manageable. The game even warns you. So everything's fine. Or so it appears. So, coal power. It works. But we've introduced a circular dependency here. Coal and water make power. Power gets coal and water. At this scale, manageable. A couple of biomass burners, you're back online. But as the factory grows, you start to want more. More output. More capacity. More power. Here's one I baked earlier. Rocket fuel. Let's take a look at this bad boy. What you're seeing produces 15 gigawatts. That's 15,000 megawatts in old money. Enough to run about 10 million gaming PCs, or one gaming PC with RGB lighting turned on. In its heyday, it took ingredients like coal and sulfur and heavy oil residue. It would blend up, crunch up, combine all of these ingredients together, and then add just a dash of nitric acid. Believe me, it made all the difference. She was totally self-sufficient, or at least I thought it was. You see, it had a problem, that circular dependency we mentioned earlier. On the fateful day she went down, she took with her 6 miners, 10 assemblers, 13 refineries, 4 blenders, 4 oil extractors, and 5 water extractors. And yes, I did have batteries. In fact, I had a building dedicated to batteries. But the thing with batteries is, they drain first, not last. So the first sign of trouble you get is that your batteries are depleting. 1 minute you're out picking daisies, next minute your batteries are draining, your trains are going down, so you have to pedal your tractor back as fast as you can. And whilst it's moving slower than a Windows update, by the time you get there, it's too late. You're stuck. So you're in a world of hurt. Batteries? Not the answer. Due for demolition, this one. But I learned something, and I built a replacement. Let me show you how I fixed it. This is a multi-phase bootstrap system. True self-reliance. 3 independent phases, each one designed to wake up the next. Let me walk you through it. Phase 1. Geothermal power. Always on. It can't fail. It's our foundation. This runs an emergency grid, just enough power to deliver coal to the main generators. Not running the factory, not running anything fancy, just coal delivery. Simple, reliable, always ready. Phase 2. Coal generators. Fed by Phase 1. Coal buffers up to the topmost generators. These ignite first. A small oil extractor spins up and starts canning heavy oil residue, providing the lifeblood to our truck network. And then, the subgrid bursts into life. Oil, coal, sulfur, iron and nitrogen gas. Now, here's the clever bit. The system combines coal and sulfur to make compacted coal, correct? Well, until it can use it, it feeds right back into these generators to generate even more power, bringing even more systems online. A chain of events is in motion. We're getting the juice we need for full power up. And Phase 3, our main event, powered by Phase 2. Coal and sulfur becomes compacted coal and oil becomes plastic, which we throw in the bin. Production is stacked. Each block can take the raw ingredients and turn it into rocket fuel. Generators start firing up. More power available. Next block of blenders come online. Then the next and the next. It's a cascade. And here's the bonus. Rocket fuel production creates compacted coal as a byproduct. That gets sent back to the coal generators, generating even more power, bringing even more production online. Naturally, I've tested it. I've ripped out cables all over the place just to see what would happen. And just like my old Nokia, she just kept going. Power rerouted, systems compensated. I could fix the problem without fumbling around in total darkness with a potato and a prayer. This is what proper engineered disaster recovery looks like. It's engineered redundancy in the system. Now, I should probably address the plastic, because there's an absolute obscene amount of it going in the bin. I'm essentially running a recycling centre backwards. Well, you see, when the main grid comes back online, right next door, there's a factory waiting to come online, and it sends out its trucks on the same network, collecting resources. And it's more than happy to take the excess plastic, and in return, turns it into something rather special. Supercomputers. That's right, the byproduct is supercomputers. And this is just one component of a much bigger system. One controlled by a spreadsheet, and I don't mean a simple one. This thing tracks every factory, every machine across the entire world. Change one number anywhere, and the whole lot recalculates. It's terrifying and brilliant. A rail network with multi-level spirals, radial curves and measured angles. Everything lined up perfectly. Brunel would either be stunned or get an aneurysm and a nosebleed. A belt connection system so simple, I'm embarrassed I didn't think of it sooner. No spaghetti, and I haven't seen anyone else do it this way. Yet. Saves what's left of my sanity. A storage system I honestly don't understand. Items come in, carousel sorts them, routes them perfectly. Every time. Never fails. I built this, I think. Still not entirely sure how it works, but it does. But those stories, they're for another day. So like and subscribe, and I'll see you next time.